All right. So your lab from yesterday, you're going to have your actual grams that you're going to figure out tomorrow from your mass. You figured out yesterday from this equation what your actual grams of zinc were. And most of the pennies came right in between here. This value is going to be a little different depending on the penny you had and that sort of thing. But this is in the ballpark of where most of you were at for your penny mass. So if you multiply that by the percentage of zinc that's in that penny, that'll give you your grams of zinc. And that's going to be your theoretical. Okay? So that's just a percent yield problem. Okay? All right, so now we're going to go through one where we have the math here. And I'm going to move this down thinking that I'm not going to use that table. I think that might be what is causing the jam ups with this deleting my ink. So I'm just going to do this without a table, but you guys are going to do it in your table. Okay? That's why I'm doing it. All right, so we've got chlorobenzene. H5Cl is used as an important chemical disinfectant. One preparation. So this is going to be preparing it. So I got to get rid of this first of all because that's going to be my product. Okay, so we're going to react benzene with chlorine to form this chlorobenzene, which is C6H5Cl plus what? And HCl. All right, so let's see if this is balanced. I've got 2 chlorines. I have 6 hydrogen. Yep, this is already balanced, so we're good. All right. They're telling us that we have 36.8 grams of benzene. So I've got, that is this amount right here. Okay. I'm going to take that and I'm going to divide it by the mass, molar mass of benzene. So I need 12 times 6 is 72. 72 plus 6 is 78. So this is 36.8 divided by 78. This is the molar mass of benzene. So that's going to give me my moles of benzene. So I've got 0.472 moles here. They told us in the problem that we had excess here and 0, 0 here. Okay. So I am going to minus 0.472. I'm going to minus 0.472. I'm going to add 0.472, and I'm going to add 0.472. That leaves me with 0, excess, 0.472, and 0.472. All right. Everybody up with me now? You understand what I just did?
No.
Okay. So this is the moles of benzene, right?
36.8 grams of benzene.
Yep, grams. I divide by the molar mass of benzene, is 78. And that gave me the moles of benzene. Yeah?
What was the actual yield of chlorobenzene?
I'm not there yet.
Oh.
Did you follow what I did so far? That I got the 0.472.
Yeah, you got the grams.
I did grams into moles. I created my cloud up here, but everything's a 1, so I just didn't bother to draw it in because everything's going to be the same across here except subtraction and addition. Okay, so do you understand where I got this value from?
Yes.
Okay, all right. So that is my moles of chlorobenzene that we formed. Okay, so I'm going to then take that. I'm going to multiply by the molar mass of chlorobenzene, which is 72 plus 36.5. So it's 108.5. And that's going to give me my grams of benzene, or chlorobenzene. So that gives me 51.2 grams.
Why did you want to 108.5?
This is the molar mass of this. That gives me, I take moles and turn it into grams. All right. Now, what we calculate in here is kind of like my recipe card. Okay. It tells me how many I should be making or how much I should be making. So you can kind of think of this as a recipe card if you want. Okay. It tells me, hey, you should be making this much stuff. Just like my recipe says, I should be making 64 cookies. But I get a cookie thief in there. And in reality, I actually only make this much. Okay. So then we're going to figure out our percent yield. Just like up here, I figured out, okay, I had 64 cookies. Cookie thief came along. I only ended up with 60. Okay. But now we're going to take this and we're going to sub in the values from this problem. So here I ended up with 38.8. But we calculated down here that we should have had 51.2. Times 100, that gives me 76% yield. Which is not as good as my cookies, which would have been about 94% yield.
So you want it closer to 100%?
Yes. If you can get 100%, that's what you want. Okay. Now, all of your homework problems, all of your test problems, all of those problems, you will end up with a percent yield less than 100. Now, in the lab, sometimes you can get more than that. For example, with your pennies, sometimes you don't get all of the zinc out of there, okay? And so that actual number ends up being a little bit higher or lower depending on how things shake out. Sometimes you lose some of the copper, and so that affects it. Some of it flakes off. So in labs, sometimes you can end up with more than 100%, but it's because of some sort of experimental error. Okay. All right, let's look at another one here. We've got potassium chromate is added to silver nitrate. So we've got K2CrO4. So put this in your table. I'm just not using the table because I keep having disappearing ink. So this is going to make Ag2CrO4 and potassium nitrate. I need to balance this. I need a 2 here and a 2 here. There we go. All right. We have 0.5 grams of silver nitrate here. What is silver? Is it 107.9? Yeah. Okay, so I've got, I need to divide the 0.5 by the molar mass of silver nitrate. So that is 107.9. I need a nitrogen, and I need 3 oxygens. 169.9. And remember, you want at least 2 or 3 sig figs down in this chart. This is my 3 sig figs. This is not 3 sig figs. I got somebody on a quiz yesterday in one of my classes. I think it was after yours, but I'm not sure because and then they ended up with the wrong answer. And I'm on your quizzes, I'm knocking you. Okay, I'm going to knock you all the way down on those quizzes and you can retake it and start learning your lessons. On the test, I might be a little bit more generous, but on the quizzes, since you can retake those over and over again, no. I'm relentless. All right. They didn't tell us how much of this we have. So what are we going to assume? Excess. If they don't tell you, you just make the assumption. Okay. So I'm going to take this up into the cloud. This time I need to do what to get it in the cloud? Divide by 2 because my coefficient 2 here. So 0.00147. Again, your cloud, you need at least 3 sig figs in there. And then I'm going to bring it down. Okay. So I'm going to go minus 0.00147 minus 0.00294. Over here, I will go plus 0.00147 and plus 0.00294. So here I have excess left over, got nothing of that left over. This I end up with this and 94. Okay. So we need to figure out the theoretical yield of silver chromate. So what we're going to do is we're going to take silver chromate, which is here. We're going to multiply by that molar mass. So silver 0.79 times 2. I need a chromium, which is 52. And I need to add in my oxygens. I've got 4 of those. All right. So the molar mass of this is 331.8. All right. This is called my theoretical yield. In theory, I should make 0.448 grams of silver chromate. In reality, what happened?
You only got 0.00147.
Well, no, I only got this much.
Oh.
So in reality, I only ended up making this much. This is my actual yield here. Okay. So if I want to calculate my percent yield, I'm going to take this value and I'm going to divide it by our theoretical yield times 100. And I end up with 93.2%. Make sense? All right. Any questions about that?
How do you know when to use? Do you usually use the number in the last row of the?
Well, they asked about silver chromate, so that's why I went with silver chromate.
Well, yeah, but is it because just this time is an exception that you use 0.455 grams instead of the?
That they told me right here. They said that this is how much you actually got. You see that right here in the problem?
Does it always do that?
Yeah. Or if it doesn't, it gives you a percent and you got to backtrack to it. You could do that. So if you have your percent yield and you didn't have this value, but you had this one, you should be able to backtrack to get this if this is X. Does that make sense? If you have this and you have this, you should be able to calculate X. X over this, whatever value at 51.2 times 100 equals 76%. You should be able to solve for x.
Divide by 100.
Divide by 100. And then multiply by 51.2. Oh, algebra, sweet algebra. How do I love thee? Let me count the ways.